again. Today we are going to do compound angle identities. So compound angle identities, we have got the one for sine and the one for cos. The one for sine has got the pattern sine, cos, cos, sine. The one for cos has got the pattern cos, cos, sine, sine. In summary, when we summarize the one for sine, we say it is psycho cosine. We say cosine. Cosine. Then for the one for cos, the pattern is cosine. Is cosine. So you can say cosine. Cosine. So yeah, let's start. Cosine. Right. So let's look at the question here. So we are given this long expression there, right? They want us to determine the value of this. Now note that when we are doing compound angle identities, each trig ratio must appear twice and each angle must appear twice again, right? So if I look at this is sine, cos, sine. So it is cosine. And then I see we are in the right conditions for us to use the formula. So we look at the formula that corresponds with this. It is the sine part. It is that compound angle identity of sine. So meaning I can say that this is the same as, so I move from this to this small part here, from the expanded part to this part, to this form. So this is going to be sine of, if you are adding inside, you must also add for sine, right? So sine of our first angle, which is 40 degrees, plus the second angle, which is 20 degrees. This is equals to sine of 60. Now you can use a special triangle to get what sine of 60 is. Alternatively, you can simply just come and punch the calculator if you want. So sine of 60 in the calculator is √3 over 2. So you are going to write sine 60 as √3. Therefore, so we say this is √3 over 2 as the value. Right? So let's look at this one now. So what do you have? If I check, this is 25, it's repeating itself there. 25 is repeating itself there. 20 is also repeating itself twice. And each trig ratio is repeating itself twice. Now I check the pattern, what the pattern is. Right? If I look at what the pattern is, you will realize that the pattern is C. So meaning this is the one for what? For the cos. This is the pattern for cos, the compound angle identity of cos. So you are going to say this is the same as cos. cos of what? Cos of 25. If we are adding trig ratios, it means inside, if we are subtracting trig ratios, it means inside we must be actually adding them according to the cos. So for cos identity, we are saying if you are subtracting the trig ratios, if you are subtracting the trig ratios, it means inside you are adding them. So that's how actually cos works. So when you're adding inside first angle plus second angle, that to then outside you are subtracting them. So we are saying therefore it means this is added to 20. So it's cos 25 plus sin. So then therefore we know that cos 25 plus 20 is 45 degrees. Now you have to get the numerical value of cos 45. You can use calculator or
Hi guys, my name is Sheldon Tatchell, the founder of Legends Barber. And right now we are doing a master class powered by Blackground.
the special triangle. So cos
Hi guys,
45.
my name is Sheldon Tatchell, the founder of Legends Barber.
So you are going to write this as root 2 over 2. Then in this way you'll be done with this question. Let's look at the next. Right, when we look at the next one, it says determine. Right, when we look at these angles, there's no angle that is repeating itself. Right, that's the first thing that I observe. Another thing, I realized that these angles are greater than 90. This is greater than 90, this is greater than 90, so it needs to be reduced. Right, so I'm going to reduce these angles using the arc method rather than using the reduction formulas. So using the arc method, I'm going to say arc sine 145 degrees, then get what the angle is, and get what the angle is there. So if you shift sine 45 145, you get.
Hi guys, my name is Sheldon Tatchell, the founder of Legends Barber. And right now we are doing a master class powered by Blackground.
The sine of the angle will be the same as the sine of the trig ratio, or the sine of the angle is assigned to the trig ratio. So we are getting 35, meaning now we can say that this reduces to sine 35 degrees. This is sine 35 degrees. Now cos, we have cos of 355. You need to do reduction. So I use the arc method to actually do that reduction. So shift cos we get shift cos 355. The reduced angle is 5. So the 5 is going to replace this big angle, and the trigonometric ratio is positive because we're getting a positive angle there. So Therefore, it means this is what? This is now cos 5 degrees positive. Okay, let me write cos 5 degrees. Cos 5 degrees cos 5 degrees plus now cos 35 is fine like this. This is cos 35. Yes. Then sine of negative 5. Negative sine negative 5. So I'm going to reduce it. So when you reduce it in the calculator, you get negative 5, meaning the trig ratio is negative and the angle is positive. So the sign on the on this angle, on this 5 here, on the answer, it is assigned to the trig ratio itself. So therefore this is negative sine 5 degrees. Now if I multiply cos 35 and negative sine 5, you are going to get negative, and this sign here will change. This multiplied by this. So you say this times this becomes negative, then this negative sign will be overpowered. So this is sine 35. This is cos 5 degrees. Then when you multiply these two, there's a plus here. You multiply the two, you get negative cos 35 sine 5 degrees. Right. So now what happens is this positive and this negative multiply each other, therefore, and the answer in the middle will be negative. So therefore this is becoming negative. Right. At this point now we check. So what do we have? So I realize that this is sine cos sine. The angle is repeating itself. 35 35 5 5. So now I can apply the reduction formula. Sorry, the compound angle identity formula. I reverse it because this is what? C C. This is C cosine. Therefore, I must say take it back. This is the same as sine of 35. For sine, this is minus 5 degrees. So with sine, if you are subtracting the trig ratios, you also subtract the angles. And this is equal to sine 30 degrees. Now sine 30 degrees, sine 30 degrees, sine 30 degrees. In your calculator, sine 30 degrees, if we try to use a calculator, then Sine 30 degrees is half. So you write 1 over 2. So this is the same as half. Is your answer. Now we can move on to the next. Right, in the next question, this is cos 70. Cos 320, I must reduce that because it's greater than 90, so it must be reduced. And I'm going to use the arc method to do that. So 70 already, it's repeating itself, it's fine. Right, so let's see what this one is. The cos, we want to get the cos of 320. So I am going to arc. What do you get? So we get 40 degrees. So it is meaning the 320 has reduced to 40. So this is going to be cos 70 here, then cos 40 degrees plus sine 70, then since we have cos, right, cos has already repeated itself twice. Now these are the last cos here on the 50 is no longer necessary because already cos has repeated itself twice. Remember, each trig ratio must repeat when you are considering to use compound angle identities. Each trig ratio must appear twice. So already cos has appeared twice here. So the last cos, the cos of 50, is no longer necessary. So I am cos of 50 is the same as sine of 40 because cos and sine are equal if their angles add up to 90, and we call them cofunctions. So cos 50 is the cofunction of sine 40. So in the place of cos 50, I'm going to put sine 40. So let's do that. So this is the same as sine 40 degrees. Now, if I'm considering to use compound angle identities, already cos has repeated itself twice, sine repeated itself twice, 70 70, 40 40. So perfect condition for me to go back and actually use the identity, the compound angle identity. So this is cocosine. What I see is cocosine, which is the compound angle identity of cos. So this is everything is the same as saying cos of the angle, the first angle. Then for cos, if you are adding inside the brackets, you should be subtracting the angles. Right. So therefore we say cos of 70 minus, that is cos 30 degrees. That's cos 30 degrees. In the calculator, cos 30 degrees, if you check what it cos 30 degrees in the calculator is root 3 over 2. So this is the same as root 3 over 2. So we're moving on to the next question that we can deal with. Next question says expand this. So to expand this is the compound angle identity of sine. Compound angle identity of sine is C co C. So to follow that, so this is equals to sine of the first angle cos of the second angle minus cos of the first angle, then sine. So basically this is what C cosine. So I have expanded it in this way, right? So now they say we need to simplify this. Let's expand this. We're dealing with this one now, and we want to prove that the left hand side is equal to the right hand side. So let me start on the left hand side. On my left hand side, I'm going to expand this. This is the same as cos. Remember the identity of cos. The identity of cos is cosine. The compound angle identity of cos is cosine. So this is cos x cos y. If you are adding for cos, you must be subtracting. So sine x sine y. Then I'm running out of space here. Then plus this plus here, the plus sign. I indicate it here. The other cos here, I expand it. This is cos x. This is cos x cos y. If you're adding angles for cos, then you must be adding. And plus sine x sine y. Now I just have to look at the like terms. So if you look at this one here and this one is negative sine x sine y. This is positive sine x sine y. So they subtract each other, the two of them. Then this is positive cos x cos y. This is positive cos x cos y. So these two, they add one another. This is 1 cos x plus cos y, cos x cos y. This is 1 cos x cos y. So 1 plus 1 is 2. So this is 2 cos x cos y. In this way, we have proven the identity. Right, so with this one again, we're going to expand this. So this is the same as, remember, cos C for the cos identity. So this is cos of the first angle theta, then cos of the second angle 60, then you add sine theta, sine 60 degrees, then plus the middle sign plus here, so you say plus the cos, this one here, cos theta, cos 60, minus sine theta cos 60. So this one is expanded like this. This is the expanded part of it. This expanded to that. Right. So now to continue, this is equals to, this is cos theta, then in the calculator this is 1 over 2, cos 60 is 1 over 2, plus sine theta, then this is root 3 over 2, root 3 over 2. Then we add here plus, remember this plus is this plus here, this plus there. Then continue with the red part. This is cos theta, so this is cos theta multiplied by 1 over 2 minus sine theta multiplied by 1 over 2. Here somewhere we made a mistake. So this one is supposed to be sine. Remember, Coco CC. So this is supposed to be sine 60. Sine 60 is root 3 over 2. Right. Now this is equals to half cos theta plus root 3 over 2 sine theta plus half cos theta. Right, let me create enough space. So we're saying this part here equals to, this is half, this is half cos theta plus root 3 over 2 sine theta. That was for this part. Then now plus plus this one now, half cos theta minus root 3 over 2 root 3 over 2 sin theta. So this simplified to that, this simplified to that, and this simplified to this simplified to that. All right, let's add like terms together. To add like terms together, we realize that now this and that will cancel, because this is positive root 3 over 2 sine, negative root 3 over 2 sine. So this and that cancel. Then half cos plus a half cos is 1 cos. So you're going to have cos theta. So the left hand side is equals to the right hand side. We have proven the identity. Right, they say they want us to prove this identity. So this part, I'm going to expand it, red. Then this is, I'm going to expand it. This is the blue part. And this minus here, I'm going to indicate with the yellow. Now, simplify this one. So this is sine. We know that for sine we use c cos cos. So it's going to be sine beta cos 30 plus cos beta, then sine 30. Then I write the minus, then this is sine beta cos 30. Okay, the space is too small here. Let me see how I can write very small things. So the red one is sine beta cos 30 plus cos beta, then sine 30 minus to the blue one now, sine beta cos 30 minus cos beta minus cos beta sine 30 degrees. However, this one must be put inside brackets because you are subtracting there, right? So you are subtracting the whole thing. So that's why I put it in brackets, right? Now the negative is going to change the signs inside the brackets. So you're going to have now this is equal to, I still copy the one in red, sine beta, right, cos 30 plus cos b sine 30 now minus sine is minus sine beta cos 30 plus now plus this change into a plus, the sign here changes into a plus here. So plus cos beta sine 30 degrees. Right, to simplify, I'm going to have sine beta multiplied by sine beta multiplied by cos 30, which is root 3 over 2 plus cos beta then sine 30 is half then minus sine beta root 3 over 2 then plus cos beta cos beta then 1 over 2 is for sine. So we are saying this simplified to dust, this is simplified to half, then the 30 cos 30 simplified to this, then the sine 30 simplified to half. But this is now you can realize that this one and this one are the same, they can subtract each other. So this and this, they subtract. And then you have this is equals to this is a half cos b plus half cos b. Half plus half gives us 1 cos b. The question is coming back again. It says prove this. So this part I'm going to write it in red when I expand it, and this will be written in blue, and this is the minus. To expand the one in red, it's going to be cos b cos a cos b plus, we're just following the compound angle identities then, sine a sine b, then put this minus here. The one in blue, let me put brackets because you are subtracting the whole thing. So this is cos a cos b minus sine a sine b. We're dealing with the left hand side now. Now what happens is this is equal to the negative sign, this negative sign here is going to affect this sign and it becomes positive, that sign. So the sign will become positive. So you multiply the positive, then this bracket and this bracket will be out. Then you'll be left with this. Then you realize that now this cos A cos B we subtract with cos A cos B. No, because they are like terms and they're subtracting each other. Then we'll be left with, now we'll be left with sine, we'll be left with sine B, sine A sine B, and sine A sine B. And if you add them together, they form 2. So this is 2 sine A sine B. Now this, we look at this. It says hence show that cos 5x minus cos 15x is equal to that. So here you're going to look for two numbers that can add to 5 and the very same numbers. Sorry, when you subtract them, so because hence means based on what you have done here. So with the first cos, according to what I have done here, this and that, and then this and this, and this is the minus sign that is between them. This. Now what I do is I must subtract two angles that can give me 5x. Now the very same angles must give you 15 when you add them, because we are adding for the second cos. Right. So those angles are 10 and 5, obviously. 10 and 5. So this is going to be, for the first, for this is, I rate 5 as 10 minus x, minus 5x. So this is cos of 10 minus 5x. Then subtract, take, this is cos of 10x plus 5x plus 5x. Then from here we expand. Right. We expand this. One is going to be cos 10x, then cos 5x plus sine 10x sine 5x minus, then put in brackets everything. This is cos 10x cos 10x. There, you're going to have cos 10x cos 5x. If you're adding inside, you must be subtracting outside. So sine of 10x sine of 5x. Now the negative sign here, negative sign will change the sign there. So the bracket will be removed, then this turns into a positive. Now we realize that now this one and this one are like terms. They subtract each other. The way this is x, right? Right, then you are left with this part and this part added together. So this is 2 sine 10x sine 5x. Then you have proven the identity. So, based on the proof that we have done, they say hence now show with numbers. This one has got numbers that cos 29 minus cos 31 is equal to sine 1 degrees. So this is guiding us. So because we have proved that the first cos has you subtracting two angles. So 29 you're going to form it by subtracting two angles. Now the second cos you are adding angles. It corresponds to this one. Now you are going to add two angles. So here those angles, when you subtract them, they should give you 29, and the very same angles must give you 31, and one of them must be a special angle. So what are those angles? Obviously that will be 30 and 1, because 30 and 1, when you subtract them, they give you 29. Okay, when you add them together, they give you 31. So one of them must be a special angle. So yes, 30 is a special angle. So we can see. Let's follow the formula now. So I start writing cos 29. I now start writing it as cos no. So this is cos of 30 minus 1 minus cos of 30 plus 1. I deal with the left hand side first. Degrees, right, degrees. Now expand. This is going to be cos 30. If you expand the cos there, it's going to be cos 30. Cos 1 degrees. You add plus sine 30 degrees sine 1 degrees. Then this minus here is this minus here. So I'm going to also write it here minus. In brackets, do the one for cos, the red one. So when you expand the red one, this is cos 30 cos 30 cos 1 minus sine 30 sine 1 sine 1. Now the negative is going to affect inside the bracket. This negative is going to affect this negative to form a positive, right? So, and then the brackets will be gone. So let's do that. Brackets must be gone. then we said this negative will turn into a positive. Now we realize that this and this, they subtract each other. Cos 30 cos 1 degrees minus cos 30 cos 1 degrees. They subtract each other. We are left with this is equals to, so you are left with this. That's that. So this is what? This is 2 sine 30 sine 1 degrees. But we know that sine 30 can be written as 1 over 2 sine 1 degrees. 1 over 2 times 2 is sine 1 degrees. Hence, they can say, hence prove this one. Remember, the first ones, for the first one, it comes from, the hence comes from cos of A minus B that you were proving, minus cos of A plus B. So we are saying, okay, this relates to that, and this one relates to that. So for 25, you are going to look for two angles that two angles, and you subtract them so that you get 25. The very same angles, when you add them, they should give you 35. And that is 5 and 30, because one of them must be a special angle. So that is 5 and 30. So the red one. So what I'll do is this. Simplify this in red. This is going to be cos of 30 minus 5 degrees. Then this minus here, black. Okay, I write it there. Then this, I'll write it as cos of 30 plus 5 degrees, obviously, plus 5 degrees. Then start expanding. So expanding the red one, this is equals to cos 30 cos 5 plus sine 30 sine 5. Then the minus sign, the black one. This one, this is here. Then subtract. So subtract this one now. This is cos 30 cos 5 plus 5 degrees minus sine 30 sine 5 degrees. Then the negative inside, the negative outside here, this negative will change the sign, this, and then the brackets are gone, will be gone. So this will turn into a positive when you multiply with the negative, with this negative here, with this negative here, and the brackets are gone. Now this and that will subtract. So you're going to have this and this adding together to form 2 sine 30 sine 5. And sine 30 it can be written as 1/2 sine 5 degrees. Sine 5 degrees. The final answer is sine 5 degrees. Right, let's look at this one here. Simplify to a single trigonometric ratio. So when I check, this angle is repeating itself there. This is also repeating itself there. Each trig ratio is repeating itself. So yeah, so it's say, okay, sorry. So yeah, it's okay, this angle there. Now this angle is repeating itself. Now this is sine and this is sine. So each angle is repeating itself there. So this is cos. Every angle is repeating itself and every trig ratio is repeating itself. So that's a clue that I can go back to compound angle identity. So this is C co C. What I see here is C co C, which I can reverse now. And see this, all this is the same as the sine of the first angle. This is the first angle and this is the second angle. So sine of the first angle, which is 45 plus 8. Since this is a minus, so we also put a minus, that is for sine. The second angle, which is angle A, is the second angle. So we're saying this is the first angle, this is the second angle. So we take the first angle, subtract with the second angle. And that's the compound angle identity, how it works. Now, at the bottom, we have got cos A. This is cos A. this is equal to sine 45, because a and a subtract over cos a, and sine 45 is root 2 over 2 divided by cos a. Right, this is the same as saying, alright, root 2 over 2 divided by cos a. It's the same as root 2 over 2 multiplied by, then flip. I know that in the denominator there's 1. Then you flip it, it becomes 1 over cos. When you change the division sign, and change the division sign into multiplication sign, this flips. So the final answer here is root 2 over 2 cos a in the denominator. Now let's do the last question. So right, now let's look at this one. This is simplify. I realized there's a pattern here. So this angle is repeating itself there. So I realized that there's an angle that is repeating itself. Right. So this is repeating itself there. This is also repeating itself there. Trig ratio, cos, sine. So this is cosecant. So it reverses back to the identity of cos. This is cos of what? Of the first angle, which is 25 plus alpha. Then the second angle is 35 minus alpha. So the first angle is called, this is the first angle and this is the second angle. Second angle is called, you add it. Since it is a subtraction there, then you add inside. So plus, okay, let me use plus, the second angle is 35 degrees minus alpha, all over cos alpha. 30 is 1 over 2. This is equals to cos of alpha and alpha. You subtract alpha and alpha, subtract, disappear. Then 25 and 35, they make 60. So it's gonna be cos 60 over cos alpha 1 over 2. Now cos 60 is the same as 1 over 2. Then cos alpha 1 over 2. cos alpha, I mean half and half out. The final answer will be 1 over cos alpha for this question. Then for this 180 minus then cos 90. For angles like 180, 90 and 360, you drop them, meaning you make them disappear. The only angle that should be left inside the brackets is the variable angle. However, when you drop 90, you know that cos is going to change into sine, and sine changes into cos. I want 90 change the name. So this is going to be sine of x. Then you determine whether the sign is positive or negative. So to determine whether the sign is positive, or negative, in the place of the variable I put 1 degree. So I check the answer that I get is positive, meaning the sign has to be positive. Then cos, it changes the name. Now it's no longer cos, it's now what? Sine. This cos is no longer cos, it's now sine x. Then determine whether it's positive or negative. You'll find out that it's positive. Right at the bottom, this is, you can't drop angles like 30. You can't drop them. You only drop 180, 90 and 360, meaning they are the ones that you can simply just make them disappear. But these ones, you can't make them to disappear. They are special angles. So here this is sine, cos, sine. So this is c cosine, which reverses back to sine of 30 minus x plus the second angle, which is x. So x is the second angle, and this is the first angle. 30 minus x is the first angle. This x is the second angle. Okay. So this is equals to sine x over sine x, then x minus x plus x cancel, you get sine 30. Then sine multiplied by sine is going to be sine squared x over 1 over 2. And anything multiplied by 1 over 2 is like you're multiplying it by 2. Sine squared x. All right. So we look at this one again. So we drop the 360. The only thing that we leave inside the brackets here is the variable angle. So this is sine y, then cos x plus, then this changes. 190 change, so you change. When you see 90, you change the name of the trig ratio, so it's cos x, cos y. Then it's gonna be positive. Then this is sine x. Then at the bottom, this is cos, sine, and the angles are repeating. So this is cocosine. It reverses back to cos of. This is the first angle, and x is the second angle. So cos, the first angle is x plus 60. The second angle is the x. And if you are adding, then inside the brackets should be subtracting. That is for cos, the compound angle identity of cos. That's how it works. Okay. Therefore, at the bottom, you're going to have cos 60. Then this is sine, cos, cos, sine, and the angles are repeating. So, right. Therefore, this is what? This is sine of x plus y. And the final answer will be sine of x plus y divided by 1/2, which is the same as 2 sine x plus y.